Hi friends, after the calculation of critical path method, that is CPM, now we are going to move ahead towards PERT, that is Program Evaluation Review Technique. In this we will be learning the calculation of estimated time. First of all, how to calculate the estimated time. You will be given three times, that is optimistic time, most likely time and pessimistic time. From that you will be calculating estimated time with the help of one formula. After applying the estimated time, you will be solving the question as usual as we have done in the previous videos. Then sometimes you will be told to calculate the variances and standard deviation. That also we will learn in this video. And then sometimes the concept of probability is also introduced in this. So with the help of normal distribution curves, we will be learning if the project is expected to be completed within a specific time, how to move ahead with those problems. Let us learn all these concepts of PERT with the help of one practical question. Now we will start with how to estimate the time. Sometimes in the questions, the time which has been taken by every activity has not been given, while the three different times are given. So in that case, you will be applying the formula to calculate the estimated time, and the formula will be optimistic time of that activity plus 4 most likely time of the activity plus pessimistic time of that particular activity divided by 6. You have to learn this formula. Now this has to be applied when in the question three times have been given. TO stands for optimistic time, TM stands for most likely time, TP stands for pessimistic time. So if three times have been given, with the help of this formula we can calculate the estimated time for that particular activity. Rest of the question will be done as it is, as we have discussed in the previous video. Another important point is sometimes in the questions you may be told to calculate the range of that particular activity. To calculate the range, you have to apply this formula TP minus TO, pessimistic time minus optimistic time. And if in any question you have been asked to calculate the standard deviation, now to calculate the standard deviation, the formula will be your pessimistic time minus optimistic time divided by 6. And if variance have to be calculated, of course we all know it will be the square of standard deviation. So if variance have to be calculated, it will be TP minus TO divided by 6 whole square. That will lead to variance. So depending upon whatever has been asked in the question, you have to calculate. Now let's see the example. Now see, in this question you have been given this path to prepare the network and three times have been given, and you have been told that you have to draw a network and find the expected completion of the project. So it is the same question that we have already done, but here we have to calculate the expected time, as expected time is not given in the question. Now to calculate the expected time, as we have done, you have to apply the formula optimistic time plus 4 most likely time plus pessimistic time divided by 6. So for every activity you have to apply this formula. So it will be 1 in the first case, 4 into most likely is again 4 plus pessimistic is 7 divided by 6. It comes out to be 4. For next it will be optimistic time is 5, 40 plus 15 divided by 6. This comes out to be 10. For third it will be 3, 12, 3 divided by 6. Next it will be 4, 16, 7 divided by 6. It comes out to be 4. Next is 10, 60, 26 divided by 6. This is 16. And next is 2, 16, 6 divided by 2 divided by 6. It is 4. Next will be 5, 20, 5 divided by 6. It comes out to be 5. And the last one is 2, 20 and 8 divided by 6. it again comes out to be 5 for the last. So this is how you will be calculating the expected time. Now the procedure to make the network is, now the first activity is 1 to 2. So 1 will be here and 2 will be on this side. The second activity is 1 to 3. So 1, 2, 3, 2 to 4, then 2 to 4 and 2 to 6 also. So 2 to 6 also we will make like this. After that 3 to 4. So this will be our 3 to 4 activity. Next is 3 to 5. So next will be our like this 3 to 5. Next is 4 to 5. This will be 4 to 5. And then is 5 to 6. This is how the network will be drawn. And now on this network you will be writing this expected time. So 1 to 2 we are going ahead with 4 hours, 4 days. 1 to 3, 10 days. 2 to 4, 3 days. Then 2 to 6, 4 days. 3 to 4, 16 days. 3 to 5, 4 days. 4 to 5, 5 days. And 5 to 6 also 5 days. This is the network we have drawn. Now we can just go ahead with calculating the critical paths CPM. So critical paths can be from 1 to 2, 2 to 6. So from 1 to 2, 4 days, 2 to 6, 4 days. So first path can be completed in 8 days. Again the second path can be 1 to 2, 2 to 4 and 4 to 5 and 5 to 6. This will become the second path. So 1 to 2, 4 days, 2 to 4, 3 days, 4 to 5, 5 days and 5 to 6 again 5 days. So it will be 17 days. The next critical path can be from 1 to 3, 3 to 4 and 4 to 5, then 5 to 6. So 1 to 3, 10, 3 to 4, 16, 4 to 5, 5 and then again 5. It comes out to be 36 days. Next critical path can be from 1 to 3, 3 to 5 and then 5 to 6. 10, 4, 5, 19 days. So out of these, this one is the highest. So we have already done highest becomes the critical path. So we will be moving 1 to 3, 3 to 4, then 4 to 5 and then 5 to 6. This is our critical path. And the project will be completed in 36 days according to the critical path. After this, you may be asked in the question to calculate the floats. So you know how to calculate the floats and how the head slack, tail slack, total float, independent float, all those things are calculated. So the first point in this question asked was draw the network that we have done and find the expected time for the project completion that we found is 36 days. Another point that has been asked in the question is find the probability that project will be completed in 41 days. So here we need to apply the concept of probability because we have to calculate the probability that project will be completed in 41 days. One thing you have to remember here is your critical path has shown you that project will be completed in 36 days, but now we find the probability that project will be completed in 41 days. Now here we have to make use of the concept of probability, that is normal distribution curve, which has this formula z is equals to x minus x mean upon standard deviation. Now in this question you have been given that you have to find the probability that project will be completed in 41 days. So x is 41. Mean is generally in how much time the project is completed, that is a critical path 36, and then standard deviation. Now you have to first apply the formula of standard deviation only on the critical path. Just see the critical path, apply the formula for standard deviation. For this purpose you have to calculate the variance for every activity, and variance formula we have already written. The formula for variance is total pessimistic time minus optimistic time whole square, and this is divided by 6. Tp minus T0 divided by 6 whole square. So in the first case, what is Tp? It is 7. What is the optimistic time? It is 1 divided by 6. So 6 divided by 6, it is 1 and whole square will be 1 only. In the second case, it is 15 minus 5 divided by 6 and it comes out to be 10 by 6 square, which is 2.77. For the third case, it will be 3 minus 3 divided by 6 square, which comes out to be 0. Next is 7 minus 1 divided by 6 whole square. 6, it will be 1 only. Then comes 26 minus 10 divided by 6 whole square. And this comes out to be 7.11. Next is 6 minus 2 divided by 6 whole square. That is 4 divided by 6. 0.43. Next will be 5 minus 5 divided by 6 whole square. This comes out to be 0. And next is 8 minus 2 divided by 6 square. It comes out to be 1. So now after calculating this variance of every activity, if you just take them up, this is the variance of each activity. If in the question you have been told to calculate the variance of critical path, so you will be taking only those activities which are concerned with the critical path. Now, in order to solve the probability concept, what you have to do is you have to see which ones are the critical path variance. So, if we look at our critical path, first activity was 1 to 3. It means this. So, first activity is 1 to 3 and the variance of that activity is 2.77. The second activity of our critical path was 3 to 4. 3 to 4 and you look at the variance of this activity, it comes out to be 7.11. Third activity of the critical path is 4 to 5 and the variance of this comes out to be 0. Fourth activity of critical path was 5 to 6 and its variance comes out to be 1. So you have to total this out. This comes out to be 10.88. This is the variance of the critical path. Now you have to convert this variance into standard deviation to convert it into the formula of probability. So take the under root of this and this under root comes out to be 3.30. So now we have calculated the standard deviation of the critical path. This is the variance of critical path and that is the standard deviation of critical path 3.30. Now let us apply this in the concept of probability. So now we have to apply this in this formula of normal distribution. We have to find out the probability that project will be completed in 41 weeks. It means X is given 41. In how many weeks the project should be completed? Minus. Mean is our critical path weeks. We calculated this 36 and standard deviation we just now calculated came out to be 3.30. So now just calculate it and this comes out to be 1.51. You have to find the probability. Now you have to see the Z table given in the last of your books. Probability Z tables will be given and you have to see the value of 1.5 under 1. Just look at those tables. So this is how the table will look like. Just see the value under 1.5 under 1. So if we look at the table over here, this is the 1.5 and from above 1. So 1.5 and 1 value is 0.4345. So now you will be writing the table value of 1.51 under the Z table is 0.4345. Now the project should be completed within this time period. Now for that you have to draw a normal distribution curve. Just check where this lies. This is like a normal distribution curve, a bell-shaped curve. The project should be completed. 1.51 will be coming on this side, 1.51. So if we want to shade this area, so project should be completed within this time period. It means starting from 0 week till this is 41 week. You have to calculate this value. So we all know that area under the normal distribution curve is 1. On the left hand side it is 0.5 and on the right hand side it is 0.5. If we look at that value from the table shows the value from 0 to Z for this portion. But we require value for this entire portion. So what we will do is we will add 0.5 into it to calculate the probability that the project will be completed in 41 days. This will be this. So you will be saying that probability that project will be completed in 41 days is this, or we can say is 93.45% chances are there that the project will be completed in 41 days. This is how the probability concepts are incorporated in the concept of PERT.